Okay, so 7, 8, and 9, using the one-to-one property to solve the log equation, we end up with, since each log is equal to a log of the same base on the left and right of the equal sign in 7, 8, and 9, all we do is set the arguments equal to each other. Those are linear expressions, and so we solve for x, and all three of those end up checking. Okay, in number 10, it's a little different because instead of one log equal to another log, we've got 2 times log base 6 of 2 equal to log base 6 of the quantity 4x plus 6. So we're going to start by using the power property in order to move that coefficient up to the exponent on the argument of the log. So then we'll have a log base 6 of 2 squared equal to the log base 6 of the quantity 4x plus 6. Now we've got one log equal to another log of the same base, and we can apply the one-to-one property to solve the logarithmic equation. So 2 to the second power is 4, and that's equal to 4x plus 6 when we set the arguments of those logs equal to each other. Then we'll subtract 6 from both sides, and negative 2 is equal to 4x. We'll divide through by 4, and negative 1/2 is the x. Okay. And then to check that in the calculator, we're going to do negative 1/2 and store that as the x. And then on the left side, we're going to need to apply that change of base property since we have a log base 6 of 2. So that's going to be 2 times. And then in the numerator, we'll have a common log of the argument divided by the common log of the base. Okay, and then that is equal to, and then on the other side, same thing, we'll have a ratio using the change of base property with a common log of the argument, 4x plus 6, divided by the common log of the base, which is log of 6. And we press enter, and we get a 1, and so we know that negative 1/2 checks. In example 11, we've got a natural log equal to a natural log, so those are both base e, and we can set our arguments equal to each other using the one-to-one property. So x squared plus 6 is equal to 5x. That is quadratic, so we're going to set it equal to 0 and see if it factors. So we're looking for factors of 6 that add to equal negative 5, which would be negative 3 and negative 2. So x minus 3 times the quantity x minus 2 equals 0, and we'll use the zero product property to set each factor equal to 0 and solve for x. So we get x equals 3 and x equals positive 2. So in the calculator, now to check those, we'll have a 3 store that as x, and then the natural log of the quantity x squared plus 6 is equal to the natural log of the quantity 5x. And we press enter and get a 1, so we know the 3 checks. Then we're going to repeat by storing 2 as the new x, and then we'll go up and grab that last equation, press enter, and we get a 1, so we know that that answer also checks. So number 11 had 2 solutions that worked. Now in number 12, we're going to apply that power property again, where we take that coefficient and make it the exponent on the argument. So we'll have a natural log of the quantity x plus 3 squared equal to the natural log of the quantity 13x plus 3. Then we can apply the one-to-one property and set the arguments equal to each other. x plus 3 quantity squared, that's a perfect square trinomial, so that'll expand into x squared plus 6x plus 9, and that's equal to 13x plus 3 using the one-to-one property. Then we're going to set this equal to 0, so we'll go ahead and subtract the 13x over to the other side, and we'll have a minus 7x. Then we'll subtract the 3, and then that'll be plus 6 is equal to 0. So we're looking for factors of 6 that add to equal -7, and that would be a -6 and a -1. So this factors as x minus 6 times the quantity x minus 1 equals 0. And using the zero product property, x equals 6 and x equals 1. So we'll go ahead and check those answers in the calculator. So 6 store x, 2 natural log of the quantity x plus 3 equal to natural log of the quantity 13x plus 3, and that checks. Then we'll store 1 as the x and check again, and that one also has 2 solutions that work.